Good morning, this is your Stat Sensei, Mr. Spensei, and this is a scenario on battery life. This is continuation from the warm-up. In the warm-up, we did a hypothesis test. Here, we're going to create a 90% confidence interval. So as a review, a company that manufactures smartphones developed a new battery that has a longer lifespan than that of the traditional battery. From the date of purchase of a smartphone, the distribution of the lifespan of the new battery is skewed. That's that's an issue because we need it to be normal. The claim mean of 30 months, so they're telling us they're claiming that it's 30 months. A consumer group tested a random sample of 60, so we have n equals 60 from a batch of 1,000 and obtained an average battery life of 28 months with a standard deviation of 8 months. So they're telling us we have a x bar equal to 28 and a standard deviation, a sample standard deviation equal to 8. That 8 tells, because it's a sample standard deviation, that tells me I'm using a t distribution. And we said the sample size was 60. All right. And they also said that we had a huge batch of 1,000. So that's our population size. So it says create a 90% confidence interval for the smartphone battery life. So let's go ahead and in your spirals, it's all divided for you, but on your test, it won't be. So here's what I would recommend doing. I'd recommend folding it in half, your paper in half, and then fold it in half again. Now that's only to get you an approximation of the space that you're going to need, but basically you've now divided into like 4 sections, and we'll go to work on it from there. Well, the first thing that you're always asked to do is give the formula. Now, keeping in mind, this part's not going to get you points on the AP, but it's the way that you get your work done. So X bar plus or minus T star S divided by the square root of N. All right. The next thing I need to do is sit there and go, well, what all information did I have? Well, they told me I had a sample mean, an X bar of 28. So my X bar equals 28. They also told me my sample standard deviation was 8. We also know we have a sample size of 60. All right, so now we can go ahead and start plugging in. When I plug in, I go, well, that's 28 plus or minus. I don't know T star yet, so I'm going to leave a big blank for it. And then I'm going to go 8 divided by the square root of 60. So I need to calculate T star. That means I'm going to have to do an inverse T. And it's going to ask you for my area. All right. And my area is going to be, since I wanted 90%, it's going to be 1, the area is going to be 1 minus 0.90 divided by 2 degrees of freedom. In this case, we have 60. So 60 minus 1. So let's plug that in. So second vars, inverse T, parenthesis 1 minus 0.90, close parenthesis, divided by 2 degrees of freedom, 60 minus 1. And there it is. Make sure you make it positive. So we have 1.6710. And to show that you know what you're doing, I would go ahead and draw the picture. Now we're centered on X bar. And X bar in this case happened to be 28. This area right here, we're going to have a lower and an upper. And we're looking for that area to be 0.90. So our area in our tail is 0.05 and 0.05 because it has to sum up to one whole. All right, so we've now done all of our work. The next thing I need to do is, and I've plugged in, I need to sit there and go, well, what is the name of this test? Well, how many samples were there? Well, it was one sample. So one sample. And it was what distribution? A T interval for means. All right. So we have that. And now that I have that, I'm going to go ahead and run my test and get my interval. So stat test, drop down to number 8, T interval. We have an X bar of 28, a sample standard deviation of 8, a sample size of 60, and we wanted a confidence level of 0.90, so 90%. And we end up getting 26.274 to 29.726. Somehow or another, I made a mistake. Stat test T interval. There it is. There's my interval. 26.274 to 29.726. This is my lower, that's my upper. So now I've done my interval. All right. I need to sit there and go, well, what was I finding the interval for? Well, let mu equal the true population mean smartphone battery life. Smartphone battery life in months. All right. Oops. So now at that point, I've defined my parameter, I've done my interval, I need to do my conditions. Conditions probably going to take from this part down. So go ahead and be prepared to put some space in there. So I have first random sample. I need to go back and check. Well, I know it's a sample size of 60, and oh, sure enough, it says random sample. So random sample of 60, and that was given. The next thing, I need to check to make sure that for independence, well, 60 times 10 equals 600. And that was out of a batch of 1,000. So that 600 is less than 1,000, which is great. So N is less than 10% of the population. And the third thing I need to check is normality. All right, so in this case, they told us the distribution was skewed, but our sample size is 60. So N equals 60. That's greater than or equal to 30. The distribution of the sample means is approximately normal by central limit theorem. So now we've taken care of our conditions and we need to go to our conclusion. All right, our conclusion. We are 90% confident that the true population mean smartphone battery life lies within the interval, and there's our interval, 26.274, comma, 29.726. So there's our lower, there's our upper. All right. And then finally, they didn't ask for it. And since they didn't ask for it, we don't have to do it, but we're going to do it because when we go in to stay in practice, we need to give the meaning of the confidence level. Well, in repeated sampling, we expect this method to capture the true population mean battery life. How often? 90% of the time. All right. That's what it looks like when you don't have the template. I hope that helps. Hope to see you on the next one. Thank you.